Hello, this is Archie, and in this tutorial I'll be showing you how to build a simple sniper bot. As you can see, like the one that you're seeing here, it's able to find new tokens on Solana. It listens to the Radium new liquidity pool, and we're able to monitor for new tokens, and then when we monitor for those new tokens, we're able to snipe those tokens through using the bot. So in this tutorial I'll show you a good overview of how it works and what's going on under the hood. Okay, so we've sent some transactions so far. Let's jump over to my token wallet to see how the sniper bot has performed so far. And there's a few transactions that happened previously when I was testing, and we have this transaction that just came through a minute ago, and another one that's also sent. So if I open this right here, we can see I purchased this token called Sol High, and this token called Sol High, I'm going to go into here, and you can see this is the token that I just sniped. If I copy the address of my wallet, I go to maker and filter, you can see I purchased over here, and we've already have some unrealized profit. So I purchased in the first, second, third, fourth, fifth, second. Okay, let me stop this here. So we able to snipe this token in the 5th second, and this is the price of the token at the moment. We can also see other successful snipes here. Aside from this one, there were 2 other tokens that were purchased. We can see here we purchased eWeed. Let's check it out. This is eWeed that was just purchased. I'll take my wallet address, go into maker again, and we can see we purchased in the 5th, 4th second, and already in profit. And what I did with this wallet, with this bot, is that after a purchase I transfer to my TG bot. So here I can go to positions, and I can see Sol High, the position in eWeed, and Ansem MW, that's probably the 3rd token. And the reason why I do this strategy, in my experience, it just gives more control over selling. It helps to maximize sales. If I automate the selling, I find that I don't make as much profit. So here I can just choose Sol High, and I can decide to sell based on what I'm seeing in the chart. So here is eWeed or Sol High. Okay, so that's it in a nutshell. That's how the sniper bot works. And so in this tutorial, I'm just going to walk you through the code. Now, if you're new to coding, maybe this might be a bit of a stretch, but I'll try my best to keep it simple. It's an overview. If there's more interest, I will do an in-depth course, maybe a step-by-step for a beginner, taking you through, the construction of everything from scratch. But here in this video, I try to cover the big picture. Okay, so first of all, let's understand what's going on. This is a simplification of how to build a sniper bot. The first thing you need is an RPC connection. What is RPC connection is, just think of it like an API call, or a way for a computer to talk to each other. In our case, we're trying to get data from the blockchain, so we need some sort of a connection to get information of the blockchain. So typically people would use different providers. You can use like a Helios. I'll put the referral in the description. Helios provides RPCs to help you connect to Solana blockchain. Shift is another good one as well. Okay, so we have the RPC connection. After we get the RPC connection, we just listen to data on the blockchain, and we're trying to listen for data specifically about the new liquidity pool. Most new liquidity pools on Solana new tokens are launched through using a program called Radium. Radium is an automated market maker where creators of tokens will put together a liquidity pool consisting of a base token and a quote token. Usually the quote is Solana. So that's why, you know, people are able to trade. So for example, if I choose this token here, Gummy, you can see we have a liquidity pool consisting of 775,000 of Solana and 775,000 of the token. So Radium is the program that is used to create a new liquidity pool. And after we get the new liquidity pool transaction, I'll show you that in a second, we extract the pool keys. So the pool keys are just a combination of public addresses that are used in the creation of the liquidity pool. There's typically about, I believe, 14 of them. And these pool keys are required to create what's known as a swap instruction, which you send to the blockchain so that you can snipe the token. Okay, so this is what we're going to cover briefly in this tutorial so you can understand. Okay, let's go here and talk about this transaction first of all. So this is an example of a new liquidity pool creation transaction. If you open the wallet of a creator of a token, you can look at the transactions and you will see one of the transactions looks like this. How do you know this is a new liquidity pool creation transaction? Well, it interacts with the Radium liquidity pool v4, and you can see that the signer, who's the creator of the token, has transferred to Radium his tokens and Solana. So this is the pair he's creating, a pair that consists of 357 million of his tokens and 5 Solana. And as soon as he creates this pair, you will see that a lot of snipers would start to snipe the new token. So this is what happened in a nutshell. In this case, this is a creation of a liquidity pool. But let's dive a bit deeper. If you scroll down, you can see the instructions that were involved. Remember, we talked about extracting the instructions used to create the liquidity pool. And SoulScan is good because it gives a nice UI. We can see that we had to create some accounts. We had to interact with the Radium program. And these were the different accounts involved in that interaction. And then we have these instructions where there's some transfers going on between different accounts. And eventually we end up with the liquidity pool created. Okay, now let's take it a step further. I'll come back in a step further, but I just want to show you just a simplified view of what the liquidity pool transaction looks like. And the pool keys look like these. They're just different addresses that correspond to the pool. So for example, this is a pool key. One of the pool keys is the pair key, and the pair key, also known as the pool ID, is a data representation of the pool. So it contains information about swaps between the two pairs, and also contains information about the volume and so on. This one's not showing right now, but that's the pool ID. So you also have the base token address, you have the quote token address, you have the market ID, which is used to create the market before the pool's created, and so on and so forth. Okay, so that's what the pool keys are. And the swap transaction, the swap transaction looks like this. So you can see here we have a swap, and you've probably seen a swap transaction many times before, you just didn't realize. And this is what the swap transaction looks like, or swap instructions. You can see these are the instructions provided to execute the swap. So what we are trying to do when we're trying to snipe is to replicate what we're seeing here on SolScan. We want to create the necessary token accounts, and we want to transfer, and we want to execute a radium swap, providing all the pool keys necessary to execute this. Okay, I hope that makes some sense. So all we're doing when we're sniping is just replicating what we can see here. This is a successful transaction. Okay? Okay. So we get the RPC connection, we listen. When we get the new transaction, we extract the pool keys, then we create the swap instruction to replicate what we can see here in the instructions, and then we snipe the token. That's it. Okay. So now we're going to jump into the code. If you are a complete beginner in coding, or you're new to this stuff, I recommend, you first of all install Node.js on your computer, which is a good, it's a package. It helps you to, it's a way to run JavaScript on your computer. I'm not going to go too deep into explaining these basic things. I think, you can use ChatGPT. There's a lot of basic videos online in terms of setting up with Node.js. You can also set up VS Code, which is a popular code editor. It's the one I'm using. The full code base we're going to jump into now. And this entire code base that contains all the logic for the sniper is actually available for purchase. So if you don't want to go through the headache of putting this all together, then you can get in touch via Discord. Right now it's just first come first served basis. Okay, but this is the entire code base you're going to get, so you don't have to build this all by yourself. And if you're beginner to coding, you just come here and you just run a script, right? And that's it. That's all you have to do, as opposed to have to do everything from scratch. Okay, let's go through the code and see how this matches up to what we discussed. The first thing we want to do is start to monitor the new tokens. We pass in a connection to the RPC connection. This is either a Helios shift or there's many other ones available. And all of this is doing is we're just listening to the Radium program, because the Radium program on the blockchain is executing transactions. Okay, so we're listening to the Radium program, and what we're saying is that when we get an alert of a new alert from Radium, we get the past transaction. Okay, let me jump back. Remember, we want to get the LP transaction. Okay, and that LP transaction is going to look like this. It's going to look like, where is it? It's going to look like this, okay? But this is SolScan making it nice for you. In reality, it looks like this, okay? This is what it really looks like. So when you see here in this code, I do get past transaction, it gives me the full raw details of that transaction. So all of this you're looking at here is the same as here. It's just that SolScan has just made it very nice for you to look at rather than showing you the full thing. But if we're going to access programmatically, then we need to get the full thing. So this is what we get back from this function. pass transaction is this value. It's this, the block time, you get the meta, you get a ton of stuff. And when we get that, if you see here, we have all the instructions used to create the liquidity pool. But if you watch down here, watch here, this is key. This is where Radium essentially used the pool keys to create the liquidity pool. And you can see they're numbered. So all these accounts that SolScan is showing is the equivalent of all these accounts here. So we need to extract the accounts array, and usually the fourth index of the accounts array is the pool ID. That is the ID that contains data about the liquidity pool. Make sense? And that's exactly what we do here. We basically look through and pass through the entire structure, data structure, and we get the pool key, pool ID, or pool address as the fourth index of the array. Around 3, 4, 5, the fourth index. When we get this fourth index, we basically remember the pool ID contains data about the actual pool keys. It contains data about the project and the pool keys involved in that project. So what we can do is, once we have the pool address, we can now extract the pool keys. This is what we want to get back. This is what all the pool keys look like. I'll just show you in a second. So this is what the pool keys look like. You have your pool address, your base address, your quote address, your base decimals, and so on and so forth. Market ID, and so on and so forth. So once we have the pool ID, because the pool ID data includes information about the pool keys, we can just extract the account info from the pool ID. Then we decode so that we can get the necessary state layout. But just to keep it very simple for you, all we're really doing here is we're just decoding the information so that we can get the pool info that you just saw in the liquidity pool keys v4. Now this is not enough. One of the pool keys in that's part of the data is known as the market ID. Whenever somebody creates a new token beforehand, they need to create a market ID. This market ID essentially is used through a program known as previously as Serum or Open Book. It helps to manage the order book of the trades. And this market ID is one of the pool keys. So we need information about this market ID and the associated other market pool keys. So here we fetch data from the market ID. And so once we have data from the pool ID and the market ID, then we're able to construct the entire pool keys. And these are the pool keys. Most of these pool keys are going to be involved here, but not necessarily all of them. Most of them will be. Okay. Remember, the reason why we're looking for pool keys is if you want to make a swap transaction like you're seeing here, or like you're seeing when I sniped, you need to have all the necessary pool keys when you send the instruction to Solana, as you can see here, so that we can have a successful swap. So these are some of the pool keys we're fetching, which is here, and so on and so forth. Okay, so now we have the pool keys. Next thing, we want to snipe the token. Okay, so to snipe the token, remember, we need to construct instructions that mimic what we're seeing when a swap is executed. So we set the compute unit limit. I'm going to pause here for a second and recommend checking out Solana Cookbook. It has a lot of explanations of the concept of how things like accounts work. You know, what is an account, what is an associated account, what are programs, what are transactions, and so on and so forth. So it's very useful, solanacookbook.com. Okay, I'm just pausing here because I'm going to start to introduce some concepts, and you probably need to do some further reading to understand what I'm going to say. When you see compute like the swap here, so we set the compute unit limit, we set the unit price. This one is typically associated with your gas fee. So this is the fee that you're paying to execute the swap. The more the fee you pay, typically the higher the probability your transaction will land quicker. In this case, we need to create what's known as an associated token account. Okay, that is why I said to read this, but I'll give you a quick overview. Every token account or token account that you own in your address is under its own public key. Okay, so let me explain. When you purchase a token like this guy, so he purchased 0.992 Solana, and that was transferred back to him. Okay, but see, this address is not the actual address that has received the tokens. If you click on view token account, this is the actual address that received the tokens. This is an associated token account that is associated with the address. So if I open this account address, what you're going to see is that the owner is the wallet address that conducted the trade, and this account is owned by the owner, and this account, its job is to store data about this specific token owned by this owner. Does that make sense? So every time you purchase a new token, what happens under the hood is you have to create a new token account address that will store data about that particular token. So if he went on to buy 5 more tokens of the same token, then you will see more signatures under here, and you will see the total balance of that token that he has. So this is what the associated token or a token account address is. And why it's important is because that is where the tokens need to be transferred to after purchase. The same thing applies to buying. In Solana, when you make a purchase using Radium, you're actually sending from the wrapped Solana. Okay, so wrapped Solana is different from normal Solana because wrapped Solana is an actual token that's used for trading. So we need to create an account, then we need to transfer Solana into that account and then convert it to wrapped Solana, and then we can then trade with that account that contains the wrapped Solana. Make sense? So you need to trade with wrapped Solana. You cannot use normal Solana to trade. Okay. Okay, so now let's go to Snipe. I hope now things will start to make sense. Okay, so first of all, we have to define what is the token that's going to enter the liquidity pool. Okay, remember the liquidity pool, you're swapping one token for the other pair. So if it's Solana and the token, then we want to give wrap Solana and receive the token back. Okay. So the input token is going to be wrap Solana. And how much of wrap Solana, you can define that. In this case, it's 0.01. Here I get the associated token address. Remember, I spoke to you. We need the associated token address because that's where the tokens are going to be sent or received from. Those addresses contain data about tokens. Then we set compute limit price and limit. We create the necessary token accounts. We transfer the Solana into the WrapSol account address, and then we basically wrap it make it into WrapSol for trading. So conduct a sync native instruction, and then finally we create an account for the token itself. So without confusing you, let's jump back so you can see what's going on. This is basically it in a nutshell. All we're doing is going through these instructions. We are setting the gas fee. We are creating the necessary associated token account so that we can send the WrapSol. So to send, we need to create an associated token account, and to receive the token, we also need its own account that's tied to my address. So you can see here, we create the authority. So I am the authority, I signed for it, and I create this associated token account. And this associated token account was created, and these were the instructions to create it. And I transferred 0.01 Sol to that associated token account. Here's the sync native I talked about. And the second time, I also signed to create an associated token account. And this time, this associated token account is the one that's going to receive the new token. Here we execute the radium swap instruction. So let's jump into that in a second. This is the radium swap instruction. We basically tell radium who the owner is that's going to pay, what is the account that's going to send the token in, and what is the account that's going to receive what is returned back from the liquidity pool, and how much, what is the quantity you're going to send. In a nutshell, that is all that this instruction is doing here. We're transferring and we're receiving the balance. And finally, we optionally close the account. We close the account of the WrapSol. This is typically done for best practice because remember when I created the account here, I spent 0.002 Sol, 0.002 Sol to create the token account. And it's used for what's known as rent. So when you close the account, you'll get your money back. So you will redeem your amount, and after you successfully close an account. Okay, so that's it in a nutshell. So now we've completed constructing the transaction, including the create close transaction. We can now send the instructions to the through RPC. And now we're at this step. We need to send so we can snipe the token. Again, if you refer to Solana's docs, you can see all the methods that I applied through the SDK. But obviously in this case, we want to send a transaction. So we want to submit a signed transaction, and we need to pass in, this is what we're sending, the transaction. It gives different options, so you can read about this in the docs. But that's all we're doing here. We're basically getting the latest block hash, and then we are constructing what's known as a transaction message, and then we send the raw transaction. There's different settings here. So skip free flights. Basically, when you send a transaction, typically there's checks that happen before it goes, and so if the checks fail, you'll get an error. What skip free flight does is it skips the pre-checks. Usually this is done with snipers because it saves time, but there's pros and cons. Max retries is the number of times the RPC node will try to send the transaction. But yeah, you know, these are just more advanced things. Here we just check to confirm that the transaction has successfully been processed and landed on chain. If the transaction is failed, we throw an error saying we failed to confirm transaction. If not, then we basically say transaction successful. And that is it in a nutshell. This is how you create a basic sniper bot. Now in this repository here, I have what is more of an advanced bot. It's called a Sniper Gito bot. Sniper Gito bot is a sniper bot that incorporates what's known as Gito. Gito is MEV software. It's a validator that's used by a lot of sniper bots. In particular, if you've used Telegram bots, I'll show you for example. If you go to Trojan or BunkBot or any of these bots, if you go to the settings, you can notice this is a thing called tip and MEV protect. And what this does is it protects you, but also you can see enable to send transactions privately and avoid getting front run. And then the tip is paid to the validator to incentivize inclusion. So a lot of bots use this. A lot of TG bots use this too, because usually it makes landing on chain a lot faster, and the probability of your transaction failing is a lot lower. If you've seen congestion in Solana before and you try to use a normal wallet, you probably experience that there's a lot of failure. So when you're able to use this tip, which I've included using Gito in the code base, then you're able to land transactions much faster and much more predictably. The second thing I incorporate into this is different rug checks. You can change minimum sol of what to snipe, max token created percentage held, a max top 10 percentage. So these are different configurations you can tweak so that you're not just sniping every single new token. You're able to filter them based on different variables. There's also different sniper configs you can change. For example, how much do you want to buy per trade? What is the minimum sol required to trade? And so on and so forth. Okay, so this one I showed you in this tutorial is a very, very, very basic version. It also doesn't include logic to transfer to a TG bot, which was the one I showed you first, but that one is inside the Gito one. And even if you are beginner coding, I also provide private support channel in Discord after you purchase, so you would also get support to set up. And once you have your API keys, it's as simple as coming into terminal and you just do run the script, and when you want to stop, you just press Ctrl+C and it will stop sniping. And that's it in a nutshell. Very simple but effective. And in the Discord, I have a channel called Hall of Fame, and in the Hall of Fame I posted some of the results I've got from using the sniper bot. Some of them were 400x, 500x, by purchasing using the Sniper bot. So if you want the entire code base, you can get in touch with me via Discord, the Discord server. Everything will be in description, so you can reach out. Let me know you're interested. I will send the details, and then you can purchase. There's also members in the Discord who have purchased. You can ask them as well, so that you make sure that this is a good fit for you. Okay, so I hope you enjoyed the video, and if there's need for something more in-depth and technical, going through these code in more detail, then I will check the comments and take from there. Thank you.